Hello students, I hope everyone is fine. In the earlier video, we have discussed about complex numbers introduction part, that is starting with imaginary number, integral powers of imaginary number, as well as what are complex numbers, its standard form, and few examples based on that topic. Now, in today's topic, we shall discuss algebraic operations on complex numbers. So we know very well that what are the algebraic operations we are having. So we have addition, subtraction, multiplication and division. So on complex numbers, how it will be effectively done. So we have Z1 and Z2 as two complex numbers. When we add it, how the operation will be done. Suppose think that Z1 is a complex number with A plus IB. Z2 is a complex number with C plus ID. Now, whenever we are adding two complex numbers, its real parts will be added and the imaginary parts will be added, because as we know about the like terms and unlike terms in algebra, how we add the like terms. Similarly, here like terms are purely real numbers. Whatever the real numbers are there, they will be added, and imaginary numbers will be added. So the final result of this one will be A plus C plus I into B plus D. So this will be the final result of Z1 plus Z2. So that means when you add two complex numbers, this will be going to be the result. If you discuss one example, 4 plus I5 and 6 minus I7. So I have to add these two complex numbers. So here, whenever we are adding 4 plus I5 and 6 minus I7, its real parts will be added and the imaginary parts will be added. So what are the real parts? 4 plus 6. Imaginary parts, I will be common. I will be common. 5 minus 7 will be the result. Because 7 is negative here, so we have to take 7 as minus. So 4 plus 6, 10 minus 2. So plus into minus, minus 2i. So 10 minus 2i will be the result. Similarly, when you subtract two complex numbers, so same thing, real parts will be subtracted and the imaginary parts will be subtracted. Suppose if you take Z1 minus Z2 minus, so what you have to do? A minus C, B minus D. So same thing, same question if I apply here. 4 plus I5, let us take some other example. Okay, while you go with the same example, another example will take. So we have 3 plus I8 and 7 minus I9. So what are the real parts here? 3 and 7 are the real parts. We have to directly subtract 3 minus 7 plus and B minus D. So real parts will be, imaginary parts also will be subtracted. 8 minus of minus 9. So 3 minus 7 minus 4 plus I into 8 plus 9. 8 plus 9, 79. So this is going to be the result in the case of subtraction. So in addition as well as subtraction, what is the common thing? So real parts will be added in addition. Similarly, real parts will be subtracted and imaginary parts will be added as well as imaginary parts will be subtracted. So when you take the Z1 and Z2 as a product, so in your product, we are taking a product of Z1 and Z2. That means we are multiplying. So what will happen? Z1, Z2. So A plus IB, C plus ID. So what will happen? So using the distributive property, you just multiply A into C, AC, A into ID, IAD, plus I into BC, IBC, plus IB into ID, I square B. So we know that what is the value of I square? Minus 1. So AC plus I will be common here, AD plus BC. Since I square is minus 1, I can write it as B. Again AC and BD are the real parts. AC minus BD plus I into AD plus BC. So this is going to be the product of two complex numbers. So whenever you are solving the problem directly, you can go with the same result. On practice, you will get this format. Otherwise, you have to go for the same simplification step by step. So let us take one example on this one. 4 minus I3 and 2 minus I5. So 4 minus I3 into 2 minus I5 is equals to AC minus BD. AC, 4 2s are 8 minus BD. B and D both are negative here. So minus into minus plus. So we will get 15. Next, plus I into AD plus BC. What is A here? 4. D is nothing but minus 5. 4 5s are. This minus 20 will get plus BC. B is negative. Minus 3 into 2. Minus 6. So 8 minus 5. 15 minus 7 plus I into minus 26. So minus 7 plus into minus minus. So I 26 or 26I. So this will be going to be the product of two complex numbers. Similarly, when you are dividing a complex number with another complex number, so Z1 by Z2. So A plus IB by C plus ID. So here we have to rationalize the denominator. So denominator is a complex number, you have to rationalize the denominator. So what will be the conjugate of complex number? That is another topic. Conjugate of complex number. Conjugate of complex number. What's the meaning of conjugate of complex number? So Z, if Z is the complex number, its conjugate will be represented by J bar, or a small horizontal line on the top of J. So which we will consider as bar in pronunciation. So we have to take the conjugate. So what will be the conjugate? If A plus IB will be the complex number, then its conjugate will be A minus IB. So in this case, we have C plus ID as a complex number. So we have to multiply and divide with the conjugate of this C plus ID. So C plus ID conjugate will be C minus ID. So same multiplication, distributive property, but in the denominator you will get C square minus I square. I into I square, that is minus 1, that will be plus 1. C square plus D square you will get. So A into C, AC, again A into C, I, AD, I into IB into C, IBC, I square, minus 1 into minus 1 plus BD. So here AC plus BD will be added here. You can take it as minus I is common or plus I is common, then you will get BC minus AD by C square by D square. This will be going to be the division of complex number. So whenever you are dividing the complex number with another complex number, take the conjugate of the denominator and multiply it and divide with the given Z1 by Z2 for whether it's fraction. So then you will get the simplified form as like this. So if you take one example on this, plus I4 divided by 3 minus I2. So next, what is the step? We have to take the conjugate of this 3 minus I2. So what will be the conjugate of this 3 plus I2? So you are going to get 3 plus I2. Here also 3 plus I2. So then multiply. 2 3s are 6. 2 2s are 4I. 4 3s are 12I. 4 2s are 8I square. So here 3 square 9. I square value minus 1. Ultimately you are going to get plus here. 2 square value 4. 6. Here 8 square I square value minus 1. 8 into minus 1 minus 8. 6 minus 8. So I will be common. So 12 plus 4 16. So 13. So 6 minus 8 minus 2 plus I 16 by 13. So this will be the division of a complex number. So these are the 4 operations that we have discussed. So let us solve these problems one by one. So first one, 1 plus I whole square by 3 minus I. So I have to expand in the form of a plus b whole square. So I will get a plus 2I plus I square by 3 minus I. So where 1 plus 2I, I square value is minus 1 by 3 minus I. So 1 minus 1 gets cancelled, you will be left with 2I minus 2I by 3 minus I. So take the conjugate of 3 minus I and rationalize the denominator. So 3 plus I into 3 plus I by 3 plus I. So 2 3s are 6I, 2I into I, 2I square, a square minus b square, 3 square 9, I square value minus 1. So minus 1 into again minus 1 will be there, minus will be there, plus 1. So here 6I minus 2 because I square value is minus 1. So 10. So 2 is common, you will get 3I minus 1 by 10. So 2 ones, 2 5s. So you will be left with minus 1 by 5, minus 1 by 5, 3I by 5. So this is going to be the final simplification of given problem. Next one, 1 plus I by 1 minus I whole power n. Here we have not supplied with any value of m, but still we have to simplify with the help of given condition. So what is that? How can we do that? First, within that bracket, whatever the denominator is given, we have to rationalize the denominator. So after rationalizing the denominator, 1 plus I by 1 minus I, you will get this condition. Then when you rationalize 1 plus I whole square by 1 minus I square is equals to 1. Now if you again whole power in, you should not forget that m. A plus b whole square, a plus, that means 1 plus 2I plus I square by 1 minus, I square value is minus 1, minus into minus plus 1, whole power m is equals to 1. Here 1, here I square value is minus 1, directly I am deducting that 1 minus 1 is 0, you will be left with 2I, here denominator is 2, whole power m is equals to 1. So 2 gets cancelled, you will get I power m is equals to 1. So for what value of m you are going to get the 1 as answer when the base is I. So I power m is equals to 1. So when we are discussing about the integral powers of imaginary number, so I power 4 value is 1. So I can replace this 1 with 4. So therefore I can say that m is 4. The next one is 5 plus 4I by 4 plus 5I. So even in this case, what we have to do is rationalize the denominator. So the denominator, conjugate of this denominator is 4 minus 5I. So multiply and divide with 4 plus 4 minus 5I. So 5 4s are 20. 5 into 5, 25. You will get minus 25I. 4 4s are 16I. Plus into minus minus 4 5s are 20I square by. So you will get as already we have discussed, c square plus d square will get. So that you can write 16 plus 25. So now like terms, which will be the like term? I square value is minus 1. So minus 1 into minus plus, that means plus 20, here 20, it will become 40. Here subtraction between these two, 16 minus 25, 9. So I. So denominator will be 41. So this is going to be the simplification of the third one. Now coming to the last one, the most typical one, 1 plus I whole power 6 plus 1 minus whole power 6. You need not any what you call expand that one. So next one is 1 plus I whole power 6 plus 1 minus I whole power 6. I can write this as 1 plus I whole square whole cube. So we have a simplification exponents of ours. A power m whole power n is equals to a power mn. So similarly, this 6 I have split it as 1 plus I whole square whole cube plus 1 minus I whole square whole cube. So a plus b whole cube, 1 plus 2I plus I square whole cube. Here a minus b whole square, 1 minus 2I plus I square whole cube. Here I square value is minus 1. This minus 1 plus 1 gets cancelled. We get only 2I whole cube. Here I square minus 1 and here plus 1, 0. You will get only minus 2I whole cube. So 2I whole cube nothing but 8I cube minus 8I cube. When you take I cube as common, 8 minus 8. So value is going to be 0. So that is what the simplification of problems based on the properties, not properties, algebraic operations of the complex numbers. So in the next section we are going to discuss about the properties of the conjugate of a complex number. Z A is equals to A plus IB is a complex number, then its conjugate will be given by Z bar or Z dash A minus IB. So if you implicate this idea to the complex plane or argand plane, so this is going to be the argand plane. So we'll be having the real line, here imaginary line. So we'll be supplied with some value 1, 2, 3, 4, 5, 6. Here also minus 1, minus 2, minus 3, minus 4, I, 2I, 3I, 4I, minus 2, minus I, minus 2I, minus 3I, minus 4I, etc. Suppose I have represented a number here which is nothing but the coordinates of this points are 4, 2I, nothing but 4 plus 2I. Its conjugate is nothing but 4 minus 2I. If you implement the conjugate idea, conjugate of a complex number idea to this coordinate point, so 4 plus 2I can be represented as 4 minus 2I. So that is nothing but it will fall under exactly on the opposite quadrant, 4 minus 2I. So 4 plus 2I, 4 minus 2I. So you can relate this one as just like a reflection of that particular original point. If it is the original complex number, that means its conjugate will be the reflection of the given point. So that is a conjugate of a complex number.